This podcast is brought to you by Craft Beer and Brewing Magazine for those that love to make and drink great beer. To learn more or to subscribe, visit beerandbrewing.com or find us on social media at Craft Beer Brew. It's the Craft Beer and Brewing Podcast, and this deep dive into hot side process is brought to you interruption-free by Mura, the global leader in modular on-demand steam solutions. Mura's boiler solutions are efficient, safe, and reliable with flexible fuel options, compact footprints that fit today's breweries, modular, expandable systems that grow with your brewery, and monitoring technology that gives you peace of mind. Their boilers are backed by the industry's only pressure vessel guarantee against corrosion, and they offer a full lineup of equipment that integrates with your boiler, from water softening to de-aeration, reverse osmosis, and more. Learn more or contact them at muraboiler.com. That's MIURA boiler.com. No surprise, we're going to talk today about hot side process improvements that'll make your brew day quicker, more reliable, and more consistent. Over the course of this, we'll get into the nitty-gritty of tank jackets, grist hydration, lauter-tun geometry, pressure differentials, kettle heating, and more, with a clear focus on lean manufacturing, reducing variability with Six Sigma DMAIC models. Vern's going to tell us what those are. Optimizing systems for the chemical and physical processes of beer making, workflow improvement for efficiency with provable ROI, and more. Joining me for this conversation are Kevan McCrummen, owner and head brewer of Vantage Point Brewing in Coeur D'Alene, Idaho. Welcome to the podcast, Kevan.
Thank you. Good to be here.
Kevan's a podcast listener, so it's exciting to have him on the podcast now. Also joining us, Matthew Whitaker, sales engineer for Boiler Technologies Unlimited. Welcome to the podcast, Matt.
Thank you very much. Excited to be here as well.
You're a longtime operator here in the brewing world. A lot of people, you've worked on a lot of breweries over the years. We're going to tap into your experience. And then also joining us is Vernon Spaulding, president and owner of Providence Process Solutions. Welcome to the podcast, Vern.
Thank you. Welcome. I'm glad to be here.
Tapping into their process knowledge will help us all understand how small design decisions have a big downstream ramification for brewers, and it is more important than ever for brewers to grow production through efficiency and yield optimization. We're going to pack as much into this hour as we can, but let's start off with some introductions. Matt, tell us all how you got into this world of brewing in this kind of process, integration, boilers, hot side, brewhouse design, all of these other things.
Yeah, I mean, that's a really long story, so, strap in, I guess.
In a nutshell, give us the 2-minute version.
Yeah, no, I started in the industry in 1990. Somewhere along the line, I'm a beer drinker myself. I found a long time ago that the brewing people in the brewer world, they're a great group of people. They're not only know how to make it, but they know how to drink it. So everybody likes a good beer, so I just kind of fell into it. Found a nice small brewery up in Green Bay that I met Vernon, and from then we really kind of hit it off and started working breweries around the country together. So again, started in 1990 to 2025. I've been doing it for a long time.
For sure. And you've been working with Mura for a long time.
Yeah, so my introduction to Mura ended up in the mid-90s. So I've seen that product evolve from what it was back then to just being introduced to the country to just recently becoming the largest boiler manufacturer in the world by a recent acquisition last year.
Cool. Vern, what's your background?
Well, I'm a mechanical engineer by degree, and I've got about 38 years experience in the automation industry, manufacturing process automation. And so came out of a variety of different industry segments, but got really into the beer industry. And I want to say that was right around 2010, 2011, something like that. And in fact, one of the projects that I worked with Matt in was the one up in northern Wisconsin. And so we have indeed been working together for a long time and have had the opportunity to do a lot of wonderful things for a variety of people out there in the craft beer industry.
Super cool. Kevan, what's your background?
Was born and raised in the Northwest. I'm from Montana. Kind of in the college times, I had the opportunity to live in Boulder, Colorado, Portland, Seattle, so some pretty big beer cities. Was in a previous life, I was a firefighter paramedic. And some of my travels brought me to Chicago. So around 2008, 2012, I was living there. Kind of during the craft beer boom that was happening, lots of breweries opening up, exciting times, lots of big IPAs, lots of new fun flavors were coming out of Chicago. And my uncle and I would get together and go out to breweries and try different beers. At one point, he remembered that he had a homebrew kit that his daughter's ex-boyfriend had given him for Christmas. And he had the great idea that we're going to start, let's try brewing a batch of beer. Seemed like a great idea. And so as many of your fellow brewers that you've interviewed before, it's a very similar story. You start off with a plastic bucket and a pot on the stove, and the wife gets mad because it boils over and creates a giant sticky mess. And so you start buying equipment and doing research and doing reading. And so I started accumulating equipment. I had the opportunity when I got off shift as a firefighter to work at a brewery chain for free that paid me in food and beer, essentially, to sweep the brew house and help on the bottling line, that kind of thing. So kind of really got the bug for brewing that way. So homebrewed for about 14 years. I attended the Siebel Institute's International Diploma Program 8 years ago. Then I took classes at Poland State University's Business of Craft Brewing program there. I got a certificate in that. Found some investors that enjoyed drinking my beer, and been brewing commercially here at Vantage Point Brewing for a little over 2 years now. So it's kind of in a nutshell. Yeah.
Cool. Well, let's start off the conversation here with a bit of a kind of baseline discussion of process optimization. Vern, why don't you kick us off, and kind of set the framework, for how we're going to talk about this kind of process optimization. Obviously, brewers these days, efficiency matters more than it ever has. There are very significant ways in order to, basically improve that efficiency, improve that optimization, improve that yield. And we're going to focus on ROI, positive ways to do that, and ways that we can think. This is brewers think about the art, they think about getting in the brew house and making things, but this is a manufacturing business at its core, and thinking about manufacturing in a way that is more efficient and more productive, but also supports the art and the creativity is incredibly important. So anyway, why don't you set the groundwork for what we're going to talk about?
Sure. Thank you. Well, based on my experience as a process engineer, one of the most important things in establishing higher levels of efficiency in different manufacturing plants is understanding process variability and understanding the input variables that you have control over versus the output, which is the result of the modification of some form of an input variable. And so over the years, there's been a lot of different models that have been out in the industry. When I started back in the 80s, there was a statistical process control, SPC, where we looked at what were called upper and lower control limits. And it was really just a matter of understanding what kind of variability was occurring within your process and being able to accept a certain amount of variability based on whatever its specification was. And then there were other programs that that came out of that, like Gung Ho, for instance, or Total Quality Management, and then even lean manufacturing became very, very powerful in understanding of just efficiencies from a human nature standpoint, and lifting things and putting setting things in order and putting boards up and trying to understand through value stream mapping your processes and identifying the areas there that you could improve upon. And then of course there was the big one we call Six Sigma, which is a 99.999% improve process reduction. So in other words, basically, I think it's like a couple, 2 out of a million or 4 out of a million defects are allowed. And in order to achieve that Six Sigma, it's a statistical value. What you really had to do is understand the nature of your process and a very high level of cause and effect relationships. And Six Sigma, it was really I won't go into too much detail on Six Sigma, but basically there's what's called the DMAIC model, which is first define what it is that you're looking at improving, then measure it, being able to have realistic measurement, whether they're temperature sensors or level probes or meters that measure your sugar content and things like that, Brix meters and that. And then being able to take those measurements and then analyze them and have some models that you could evaluate cause and effect relationships, and then define what your improvement opportunities are. So you're proactively injecting process change for an improvement, and then of course control is the last letter of the DMAIC model. And control means maintaining those gains that you are able to achieve early on in your Six Sigma process. And it's a continuous process. It continues to go over and over. And so, understanding the model then, we then have to take a look at how do you then control the process? What are some of the things that you can do to determine what a change in an input variable could do to a change in an output variable? And so in the world of programmable logic controllers, which is where I came from, I worked with companies like Allen Bradley and Eaton Corporation and that, we had what we called single loop controllers. And those are real basic, simple controllers. We call them bang bang controllers. And basically, either was if you've used a presence sensor, a photoelectric sensor, and let's say on a can line in a beverage plant, you notice that a can was present, then a conveyor might operate a certain way. A sweep might move one way or the other. And so those are real simple. They don't take a lot of control technique, a lot of programming to support. But then we have, what are called closed loop controllers, and those are controllers. Typically, they're analog. And if you want to maintain level in a tank, for instance, you use a pressure transducer, and when it gets to a predetermined level, then you turn the system off, whatever is feeding that tank with whatever liquid you're putting in it. And that's a real simple type of a analog control. And then of course you can get into more exotic control techniques like PID, proportional integral derivative controls, and those use mathematical models to determine how you can make a change in a variable without causing what's called overshoot. For instance, let's say you're heating a kettle or something like that, and you're turning the steam up on a kettle, and and you're opening the inlet steam valve, and let's just say the kettle has jackets on it instead of a calandria. And your temperature is rising to a certain point. You don't want to overshoot whatever that temperature is. So you want to be able to control and understand the nature, the behavior, the personality of that control loop. That's where you would use more sophisticated PID control. And that's even a relatively simple. It's been out since I want to say it started like in 1942 or something like that. I mean, it's been around a long time. But now today, everyone is hearing this term artificial intelligence, AI, and so what does that play in the future of control and automation? In my opinion, it would be taking a look at multiple variables and understanding the interrelationships of multiple variables, not just one or two. And then being able to use predefined algorithms that are then updated automatically through AI in order to produce a finished product that's desirable to the brewmaster. And so I haven't seen that yet in my career where AI has actually gotten into multivariate predictive model control. But it is something that I believe by maybe 2030, we're going to see that happen out into in a variety of ways in the manufacturing industry. And craft beer, I think there's certain elements of it you could probably use, but we don't want to, I feel, based on all my experience with craft brewers, I feel we don't want to ruin the craft of craft beer making. You can't have a machine make your beer. There are just some things that human beings need to be involved with in taste and touch and that sort of thing. But one of the important things, getting back to the brew house, if we take a look at, let's just say we put constraints on the input like a hot liquor tank, and then the output would be your knockout heat exchanger. And let's just focus within that realm. Heat is probably one of the most important variables that we can take a look at. And if you don't have good heating systems that's reliable, then you're going to have a lot of variability. And so that would be the first thing that I would look at. And, working with Matt at BTU for years and years, we've done, a couple dozen plants together. He has such a wide knowledge base of steam systems and traps and that. And I thought maybe it might make sense to maybe hand the baton over to Matt and talk a little bit about, like, Matt, for instance, when we talk about steam consistency, what are some of the things that you see out in the marketplace from a steam system implementation standpoint that can reduce some of that variation?
Yeah, thanks, Vern. I mean, that's a great question, and if you ask 100 different people, you'll probably get 100 different answers. But being involved in all these facilities, I see the same mistake being made over and over. It's consistently. It could be from properly piping traps to heat exchangers, trying to lift condensate, trying not putting in trap drip stations where they need to be to get good consistent steam. But I mean, it always comes down to the proper generation of it, right? If you have a boiler design that's not made or it's not going to give you consistent steam or give you carryover, which is considered wet steam, you lose a lot of energy that way, because steam, we're using latent energy to as a workhorse to transfer heat. We're not using sensible energy, and latent energy is basically a phase change of a substance. So that's how we measure it. And if we're not putting in the piping system correctly, insulating the piping system properly, and making good connections to jackets or calandrias or heat exchangers, CIP systems, that plays a very, very important role to how the equipment is going to operate. And you were just talking about, those variabilities. I mean, you can have a great PID loop that's set up correctly in one application. You want to take that mirror to another application, and it doesn't work. And it could be simply things aren't connected correctly on the steam distribution and production side of things.
Kevin, in the practical application within the brew house, how much variability do you see, and how much does that impact, the way that you make beer?
Well, thankfully, I had Vern and Matt install my system, so there's not any variability, essentially. We're 2 years in, and only had one issue with one steam valve that got stuck open, and fried a batch of grain that way. But otherwise, no, I really don't have any complaints. Going from a homebrew setup to a very nice QTS system that was professionally installed by Vernon and Matt here, I really can't contribute too much to that, unfortunately. Just having the steam available and all the valves and PIDs and PLCs and all those things working appropriately is obviously important to me as an owner and a brewer. And I have very little complaints at this point. So, well done, boys.
Well, thank you. Thank you.
Yeah, thank you. Yeah, I'm glad you're making good beer. That's what it's all about.
Well, and I know, Matt, when you and I worked in the past on other projects, there were always issues with the wet steam downstream, drip legs not being in the right locations, for instance, or I remember one job you and I worked on. I shouldn't mention the name of the company, but they were pushing steam up like 30 feet or something like that to their condensates. They were pushing up 30 feet, and they couldn't figure why their traps were flooded out on them. And I thought maybe you could share a little information on some of that kind of stuff. How do you get the water out of your system? To me, that seems like the biggest issue that I've faced anyway.
It is. I mean, if you have a modulating load to I don't care if it's a kettle or if it's a calandria or heat exchangers, if it's modulating, you can never really lift condensate. You want to collect it and pump it back. If you're going to try to lift it, you just need to know what you're getting into and understand the variables and the problems that are going to come with it. But that's probably one of the number one mistakes that I see in a brewery, that they're trying to lift condensate. Remember, 1 pound of pressure can lift 2.31 feet. So trap is sized based on differential pressure. And if I'm trying to lift that condensate 20, 30 feet, I have to have that pressure outside of the trap. And if I can't evacuate it because the modulating valve starts closing off and I don't have the back pressure, that heat exchanger will simply stall. And when temperature starts dropping, the PID loop will say open up valve, and it'll start putting steam into that heat exchanger with a bunch of cool condensate. And it starts doing the phenomenon called water hammer. And if you ever heard somebody taking a hammer alongside a pipe or to the heat exchanger, that's not a good thing. It causes damage to the heat exchanger, to gaskets, to valves, to piping, and actually could be a very dangerous situation. So, I mean, again, that's probably the number one complaint I have when we talk about it. It's either somebody didn't want to spend the money for a collection tank and pump, or they didn't know how to do it. I've seen a lot of good contractors out there that know what they're doing. They can pipe well. But, a lot of people look at steam and steam piping as the black art. Steam production as a black art. And there's a lot of people out there can do it well. But sometimes that language or that communication to the contractor that's installing it just doesn't happen. So having somebody around that can point them in the right direction, have good drawings, good P&IDs, to me is a good start and successful installation. But everything comes with a cost as far as maintenance. I mean, we don't buy a car and never change oil, right? Things need to be tested and adjusted and looked at regularly, especially when you're dealing with steam.
What about like steam traps, cleaning them out? Remember that one plant you and I went into, they hadn't cleaned them out in like 3 years, and they couldn't figure out why they weren't getting good steam water removal from their system. And that what are your thoughts on that?
Yeah, so water treatment, pre-treatment to a boiler system is very important. And Kevin, if you remember in your plant, I wouldn't even start it until we had chemical on site and we're properly injecting it. With that, we provided soft water to it. I don't care what brand it is. Mira has a great chemical program that they call it their CSLP. They have products that it's for their combined solutions and life cycle partnerships for their customers. Oh, there it is. I think we got some. Kevin's showing me his chemical right there. It's great. He got some renewal. But yeah, so Mira's got a program because it is a low water volume type boiler. It's high heat, high output, comes up the steam in a full operating pressure in 5 minutes. We need to make sure it's no different than any other boiler. All boilers require treatment. And part of that treatment, Vern, to answer your question, is steam pipe. It's a condensate neutralizer. It contains amines, which is, when steam changes state from liquid to a gas and then recondenses, it forms carbonic acid, and you have to neutralize that. If you don't, it causes corrosion in your steam piping and settles out at low differential pressure areas like the steam trap, plugs up your strainers and things like that. So step number one, get the right treatment program, give it the right water, have your water tested so you know what you're getting into. And at that point, we shouldn't be plugging up traps. We need to be testing them regularly, but cleaning them out and them plugging up like that, that's not typical.
We talked about process variability. I mean, you just mentioned the types of chemicals that you put into the boiler feed water tank, and that. What are some of the things, like when you run a test on a feed water system? What do you physically test, and how do you control that? Like, I remember we put a lot of pumps in on boilers that pump the various types of chemicals into the feed water tank. What's that loop look like? It's not an automated system, is it? Or is it?
I'm not sure I understand the question.
For instance, there's when a chemical person that the plant hires to come in and run a test on the boiler feed water, for instance, and they run those tests every day. What are they testing? Are they testing for pH? Are they testing for phosphatates? What are the different chemical elements that they look at?
Yeah, so depending on what chemical program you're using, some parts of the country, there's different blends for certain customers. There's certain blends if you're using a lot of makeup water versus condensate return. So it all depends on the program. But yeah, I mean, in boiler water, you're always testing the type of chemical you're using. Like Kevin, you're holding up, you use a sulfite program. So you're going to check for residual levels of sulfite in your boiler. We recommend a silica-based program for a Mira system. So we would check for silica levels within your boiler system. All boilers, we're going to be looking at pH and conductivity, things of that nature. We'll be looking at hardness coming into the feed tank and into the boiler, because we know hardness will precipitate out in high temperatures. And listen, we're boiling water at 100 psi, we're 338 degrees. So if you have hardness in your water, it'll precipitate out, attach itself to the heating surface, eventually accumulating itself and eventually insulating the boiler and eventually causing damage. And in many cases, premature failure of boiler room equipment. So if you want to spend, thousands and thousands, hundreds of thousands of dollars in boilers, and you don't want to spend, the maintenance costs of adding chemical, you're going to prematurely fail it. I don't care what brand of boiler, that's any brand.
Yeah, Vernon, I was going to say that what I check for is TSS, TDS, pH, conductivity, and I can track that either weekly or monthly, depending on what our brew schedule is. In wintertime, we brew less because we have mostly tap run sales, and our production slows down, and sometimes that speeds up. So we test that more regularly then. And we do regular blowdowns. I'm going to check the quality of the water as it's coming out the blowout, and otherwise, like I said, everything's been great. So it's been working out having that the boiler premix. But we got a steam boiler fluid that we use. It just doses in line as the boiler feeds up with water, and everything's been great so far.
Kevin, that's like, use it to my ears when you say that. So I'm so glad you're doing it. That's excellent.
Well, and that, if you don't do that and you get buildup on your heating elements inside the boiler, you're going to lose thermal efficiency and the temperatures. This is an assumption, Matt, please correct me, but won't that affect what the actual output temperature of your boiler is? The steam temperature?
I'm going to take that comment and hitchhike it back to steam quality. Carryover is a phenomenon when we have droplets of water leave your boiler, and that can happen multiple different ways. Number one, if you're not controlling conductivity in your boiler, it's an exponential curve of how much carryover you have based on conductivity level. The higher the conductivity level, the more likely you are to carry over to the system. And then you're losing your latent energy to the sensible end, because we want the latent energy to do the work, right? And traps can't keep up. We get hammering in the system, but also with scale buildup, you're losing capacity. So you have high conductivity, or if your boiler's underfired, if it's overfired, you can have potential carryover issues. But also if your load is larger than what the boiler is able to produce, you'll get carryover. So if you're inflating the boiler with scale, trying to fire that boiler and make the same steam output, you don't get the same heat transfer, so you're not going to get the same output. Thus, you're reducing the amount of capacity to the steam system. So sure, you could have that carryover situations, at that time.
Well, and then earlier you mentioned soft water in a boiler, and I do remember from our experiences together that boilers will work with soft water, polished water, and reverse osmosis water. Of the three, RO water is I believe the term is that's candy for a boiler. Boilers love RO water, but from an efficiency standpoint, because you're removing all the solids from the water, you're using less chemicals, and that's an more efficient operation as well, isn't it?
Yeah, so using RO water, it depends on how much condensate you return versus how much makeup water you have. Because when you change state and recondense that steam back to a liquid, it doesn't have a lot of conductivity. So the benefit of introducing RO water to the system isn't that much. But when you have a system that might be using large amounts of steam in their processes and using a lot of makeup water, and RO water, using RO water starts making a lot of sense. There's payback. Your blowdown rate decreases. You could be at a 15% blowdown rate and then to a 1 or 2% blowdown rate. But again, in most systems, they use steam somewhere. They could be losing it from leaky traps. They can use it from processes that have direct contact, with steam, like they're keggers, right? They use steam. They don't return their condensate. So if you're doing a lot of that, you can definitely benefit from using reverse osmosis. And I've always said using RO water with a good chemical program is probably, the best thing you could do in exception to having a priest come and bless the people, of course, in the boiler water. So
Let's try to walk through some of the the ways that heating finds its way through this hot side process. And if I'm thinking about it in a linear sense, we start with basically heating hot water, but then also strike water, and then heating, potentially also maintaining some heat to the mash vessel itself. What are some of the efficiency concerns, and some of the points that brewers should be paying attention to, with that kind of front end of, the hot side process, and some of the kinds of, whether it's efficiency optimizations or potential pitfalls of certain design that hit some of, those early pieces of the hot side process?
Well, Matt, my thought on that is first you have to have consistent temperature of steam. And so some of the things that I know you and I have noticed in some plants is based on pipe diameter and very variable loads of other pieces of equipment in the plant. Let's say you're running, you're mashing in, let's say, and you're running steam on your mash tun, and your hot liquor tank, you're striking, you're consuming water. So now the hot liquor tank's water volume drops. Let's say that's being backfilled from the knockout heat exchanger on a prior batch that was done, but it's not quite at the temperature it needs to be. So now we open a steam valve to the hot liquor tank. At the same time, we're running the striking mash in the mash tun. You're going to see a variance if you don't size your pipe diameters correctly. You're going to see a variance in your pressure. And as your pressure drops, your pressure steam temperature curves are affected there, and it's going to cause some variability. Am I going down the right path there, or is there something more to it than that?
no, I mean you're spot on. We talk about when we explore a brewery, when we look at their Gantt chart of the timeline of when they start brewing in the morning and when they finish at the end of the day. Looking at each process and what time of the day they're going to do each process and totaling it up on the bottom. We can't just say we're going to run all processes all the time, every day at the same time and say we need this much horsepower. We try to come up with a plan that's a lot smarter than that, right? But with that, we size our piping because steam is a compressible gas. The higher the pressure you operate, the smaller pipe diameter we can use for installation. So we look at that with all connected loads to the piping system to make sure that if you're gonna mash in and start making some hot liquor off the same steam main, that we size that appropriately to accomplish that. And again, these are our conversations we have up front. I mean, how much hot liquor do you have, and how quick do you want to recover? Because that's the answer. A BQ is a BQ, and it's raising 1 pound of water 1 degree, and knowing how many degrees we need. And how long you want to get there is really the magical formula of how big we need to size the boiler and what size piping we need to provide to that particular piece of equipment.
Well, and so we talked about getting establishing good clean steam in the boiler, transmitting that steam through piping systems that are properly sized with steam traps that are getting the water, the condensate out of the line. So now we're actually injecting the steam, let's just say, into a jacket on a mash mixer, for instance. The heat transfer of that mash tun, the design of the mash tun tank, is a very important element. And I don't profess to be a tank designer, but in working with some of the people that Matt, you and I have worked with, I know that there's a term, it's called the annulus space, and that's basically, and I apologize if to our tank manufacturers if I butcher it, but in my mind, what it means is it's how wide the jacket is on the tank, how deep it is, how thick the jacket is on the tank. So if you have a jacket on a tank that has a thicker annulus space, it means you have more volume that steam can flow through the tank, and thus create a higher energy in the tank, which means it can raise the temperature of your mash at a quicker timeline than before. So there's some efficiencies there. I mean, all of the work and energy and cost to get the steam to the tank And sometimes that transmission distance is pretty long. Some of the plants that we've worked in are, we're looking at hundreds of feet between the main manifold off the boiler and where the brew house is located in a plant. And so, that's a factor in my opinion, is trying to understand. So, our listeners out there talk about purchasing new brew house systems, and that would be something we definitely would want them to ask their tank manufacturers, and that what is the thermal heat efficiency of your tank, and what is that annual space. It's in some cases they can control that, and they being the tank manufacturers can control that. Based on the type of steam jacket that's used. And in other cases, you get what the tank jacket supplier gives you, and that's all you have. But you can still affect the heat transfer by how tall up the side of the tank your jacket is as well. So the surface area and then the heat transfer through the annual space of the jackets is a factor. And understanding these variables is important. Now, you're not going to change, for instance, the annular space. It is a fixed element. It doesn't change. But understanding what that is and how your tank behaves, I think is an important factor. And, and another thing is, we talk about heating mash up. In some cases, in the northern climates, that mash, the typically mill in the night before a batch in the morning. And depending on where the tank and the grist is located, that can be relatively cold. And so if your bulk grain silos are outside and let's say you're doing a direct milling, for instance, that's a cold volume of grist that has to be overcome with your foundation water and your strike water temperature, and that as it gets up to speed versus the summertime. So understand. So if you just put a temperature in a timeline, just say, well, we're gonna mash in for this period of time, and we're gonna need heat for this period of time. Without actually having some feedback loop, like obviously an RTD or something like that in the tank, actually measuring what it really is. There's variability there, I guess, is where I'm trying to go with the conversation, and understanding what that variability is seasonally, I think is something, and Kevin, you probably seen that way up in Coeur d'Alene. Winter times get really cold up there, and being able to understand that, hey, this might take a little longer to get to temperature because of the fact that your medium is so cold is a factor to look at as well.
Yeah, it's not too bad actually. In the wintertime, our inside temp in the grain room is usually 60 to 65 degrees. Grain's pretty consistently 63 to 65 degrees, almost year round, just because it is relatively cool in the summertime too. So I don't really have too much of that variability. But yeah, just as a brewer, there's plenty of online formulas or calculators you can use to calculate what your grain temp is and what your target strike temp is. And it'll do that math for you, so you know what your strike temperature for water should be. I had a 3-vessel 15-barrel system, and because I get you guys in my pocket, let's see, this steam system seems to be very well sized. Matt, correct me if I'm wrong, I believe it's a 1.75 million BTUs per hour unit. So when I need hot water, it creates it very quickly. And then also we sized our hot liquor tank and our cold liquor tank at 40 barrels for a 15-barrel system. So you do multiple turns in a row and not really have to worry about having to heat up any amount of water, because it'll fill and heat up appropriately during the brewing cycle. So I got a very
Kevin,
nice system that I'm happy with.
Yeah, Kevin, I know that your kettles, when you talk about the annular space burn, the size of the annular spaces can tell us how much steam get in, the latent energy we're able to transfer. But if you have a smooth surface annulus versus a ribbed annulus, the ribbed will give more turbulent flow. So that will give a more linear decrease in heat transfer, where a smooth one will give more of a sharper decrease in heat transfer coefficient. So again, I think, understanding not only having good quality steam, but also having that ribbed or that turbulent flow throughout the jacket helps the situation with that heat transfer coefficient.
And then if we transfer over to like a kettle, then you can have either jackets on a kettle, or in some of, I don't know, half a dozen of the projects I've worked on, we've used internal calandrias and external calandrias. And in my experience, those seem to heat in a kettle environment. Those seem to heat the wort up to at a very fast temperature, much faster than a jacket on a tank. And that's just been my experience. And Kevin, I think we've got an external calandria in your plant, don't we?
Yeah, the boil kettle is a 2-zone, steam heated, jacketed, and then also we have an external calandria. It's a beautiful thing to be able to be boiling as soon as the kettle's full.
No, I was just saying, I mean, but isn't that also talking about, when you do internal calandria or external, and I'm not the expert on it by any means, but isn't that all have to do with coefficient heat value and surface area to be able to transfer that heat appropriately?
Well, I was just going to say, and again, I'm not a calandria designer, so for those who design calandrias, please forgive me, but I believe it's a shell and tube type of a device. So the more surface area you have, the more tubes you have, the bigger the diameter of the calandria, the more tubes you can have in it. You're going to get a more aggressive heat transfer, and so those are sized, I know, specific to the barrels of if it's a 15-barrel brew house, they're sized accordingly. Because I know in the 60-barrel brew houses, I put a few of those in with internal calandrias that were actually inside the kettle itself. Those were much bigger in diameter than the ones that we did for Kevin's plant.
Kevin, you mentioned sizing your water supply for a 40-barrel system, even though you're on a 15. Talk to us about the cost impact of that, and in a real-world brewery operation, what that ROI looks like on that additional investment, and what that allows you to accomplish in practical terms, as a brewery brewing on a 15-barrel system.
Sure. So yeah, obviously the capital expenditure on buying more stainless steel is higher than if you buy a smaller size system. The way that I looked at this build for Vantage Point Brewing was to, at every opportunity, try to increase the efficiency of the entire brew house. So my plan as head brewer and majority owner and CEO, a COO, and all the things that we do here as most of us do as owners, brewers. There's a lot of time that goes into a lot of different things. So in order to maximize the brew house, or rather minimize the brew house time and maximize the efficiency, there were certain things that we threw a little bit of money at to increase that efficiency. One of those was oversizing the CLT and the HLT. That way, if and when we ramp up production, we only brewed last year in our second year about 350 barrels, mostly through taproom sales. We do a little bit of limited self-distribution, but right now we're leaning heavily into the brew pub. So that sizing those tanks allows us, if we do grow and get into distribution, to be able to do turns faster. If we can crank out 3 or 4 turns in a day, and I can have it myself or one other person do it. Those are the kinds of things that I looked at in brew house design. So yeah, there was more upfront cost. Thankfully, we bought the steel and stuff before COVID happened. So we actually get a very nice system for, relatively inexpensively for, as dicey as their system is, we got a pretty good deal on it. So it was worth it to size it up for production if we hit that mark.
If and I know this is going to probably be hard to kind of dive back into the memory, but from a percentage basis, how much more do you think that cost, beyond buying, a system that might have been sized directly for that 15-barrel system?
That's probably a better question for Vern. Vernon's done a lot of the costing and pricing and financials for a lot of breweries. I would guess it's probably 150% now, or possibly higher. But I don't have that statistic.
I'd have to take a look at the numbers in that. The jackets versus a calandria, if I had to guess, and I'll look, I can look at the numbers later, but you're probably looking at for just the kettle. If let's just say a kettle is let's just say $30,000 or something like that. With a calandria, you're probably looking at 40, maybe another 25%. For an external calandria, but it does provide a much faster cook, to get to boil in that. So that's a curious thing, Jamie. I should do an analysis on what specifically from a financial standpoint that means in time and energy systems, and what the payback is on that. And I'd be willing to bet the tank manufacturers we work with already have that data. But if I had to guess, I would say about 25% additional cost to go with an external calandria.
Yeah, I'm sorry if I misunderstand the question there on sizing that versus 15. You're doing a 15 or 30 barrel versus a 40 barrel Whitaker tank. That's kind of where my mind went on that. Otherwise, the time spent on waiting for the kettle to heat up. Once you transferred in, waiting for half an hour to an hour or more, depending on how inefficient your steam is. Being able to boil. I mean, I can be boiling while I'm filling halfway full, or as soon as it hits the full mark, I can be boiling and add my, my bitter and hop addition. That all those times spent, all the minutes spent shaving off brew days is increases my ability to do a lot of other tasks in the brew house, which is the ROI on that is somewhat immeasurable, I think.
Well, and that's a good comment, and so far we've been talking a lot about steam systems and efficiencies on the process of steam, but there's a lot of other efficiencies, and we're talking about efficiencies in a brew house that can be associated with lean manufacturing, and that's the human element of making a batch of wort in the different types of equipment you put in a plant or the processes that you deploy in order to improve human efficiencies. And I know, Kevin, you had a couple items you were going to talk about specific to that as well.
Just from the standpoint that I don't understand the physics as much of electronic or physical or steam characteristics, and I'd have less to contribute on that end, and more so for having utilized you guys to increase those efficiencies so that I can be more effective as a brewer and an owner.
I think and I think in this current context, say if this was 10 years ago, labor was a pretty easy thing to come by at a relatively inexpensive rate. In this post-COVID world, it is absolutely not that at all. And so reducing labor costs is important. And, it does look like, again, from this manufacturing efficiency standpoint that you talk about, Vern, reducing some of the human labor necessary to do this is important. Finding ways, and I think when I think about craft breweries, I think what you're talking about here, Kevin, makes sense, that you can brew in a 15-barrel system. You don't need to go, install from the outset a 30-barrel system to get the kinds of manufacturing efficiencies that you'll want in the future, but you can project to that future and in a way that allows you to brew currently on a 15-barrel system, brew at the kind of frequency to have fresh beer, now in the first 2 or 3 years of the brewery, but then also have a clear path to growing production on the same brew house without installing another larger sized brew house, by simply taking some of these steps at this early stage, designing with a moderate but understandable additional investment. You've created a pathway for much greater efficiency in production. So now you can do 2 or 3 turns in a day on the same system if you get to that volume, a few years from now, and now need to do that without having to build a whole system. Talk about some of the other kinds of efficiency, kind of approaches that you all build into systems to allow for that growth, but without requiring just large batches, large, kinds of production systems that are pretty unwieldy for small brewers. On that starting thing, you really just don't want to be brewing on a 30-barrel system. That's a lot of beer for a small brewery to sell. Being able to think about a smaller system that can scale effectively and cut time out all those phases is a really interesting way to think about brew house design.
Yeah, that's exactly right. The plan was to stay as nimble as possible. I wanted a system that was highly flexible. I can't do decoction, but I do step mashing. So it's a 15-barrel, 3-vessel. I got a dedicated mash tun, a dedicated lauter-tun it's got a rakes in it and a grain-out plow with a bottom dump on it. That way, it's pretty easy just to drop the plow and do the bottom dump and grain into a self-dumping hopper that I have. Between 1 and 2 trips at the farmer's truck, I'm grained out. Start cleaning up on that. The external calandria, get that stuff boiling, wort's boiling in no time flat. So that's really efficient to blow off all that SMM. And then we got a 2-stage heat exchanger for knockout. So it's a water and glycol chilled. I wanted that one to speed up the knockout process, but also because we try to focus about a third to half of our lineup on kind of continental style European lagers. So I wanted a system that would knock out quickly to lager temp, be able to pitch and be on my way again. We went back and forth for quite a while on whether I was going to do a 7-barrel, a 10, a 15, a 20, what the right size was for the brew house. Eventually settled on a 15, and then added 15 and 30-barrel fermenters. So I have 2 15 conicals, 2 30-barrel conicals, 2 15 horizontals, and 2 30 horizontals. Again, so like you stated very well, the kind of plan was to start off knowing that our taproom sales and initial sales would be a little bit lower, and then to position for growth later on down the road. I think we did a very good job of doing that. Now we just need to see where that growth goes. And now that the distribution chain is, I'm kind of taking a hit, and the brewing industry in general is where it's at right now. So, but yeah, I still feel really good about, the way we positioned the brew house and the types and styles of beer that we can make relatively quickly and cleanly. And then we're ready for growth if and when that we experience that.
Matt, from your perspective, are there other things that you see in these kinds of installations that create that kind of future efficiency, that also manage some of these labor costs, also save time and allow for additional efficiency out of a single installation like that?
Yeah, I mean, so I've always been a believer that there's the right technology for the right application. With Mura, specifically, it's a modular style design. So if you're going to start now, contemplating, today's sales and want to go into something, with the modular style design, just like these little mini water heaters that are out there, you can, if you have a capacity for one size now and you need to double or triple it or quadruple it, you could just stack these boilers together and have them communicate and operate as one. So that's scalable, right? I mean, that just makes, for somebody that's wanting to grow in something, there's some infrastructure things we could do up front and then grow into their processes later on. So absolutely. And then with, working with, Bernie, we're just kind of going back on some of these other conversations. Vern does he does a 3-phase approach to his project. And his first phase is financial. And Vern, where do you, and I think you used that tactic when you initially talked the cost of goods sold, what it's going to cost to build it. You take in consideration some of the things that Kevin's doing with, maybe brewing heavy 2-3 days a week and freeing up time for the rest of the week for his other duties, which sounds like it might even include janitorial. I don't know. Kevin, does it?
I don't.
Yeah, maintenance, repairs, janitorial, HR. Yeah.
the joys of being a brewery owner, huh?
Absolutely.
You do everything.
Yep.
So, well, there were a couple of thoughts that I had when you were talking about modular, Matt. I thought, in addition to, for instance, like Mura, you can put multiple boilers in line with each other, which is a pretty cool thing for future expansion. But one of the other things I know you and I were kicking around was some sort of like a modular boiler integrated system that would have like the feed water tank, the blow down separator, the water conditioning system, all on a common frame, so that when we get it to a customer site, it's all pre-piped and done. And I think there could be some efficiencies there from an installation standpoint. I thought that was one of where you were going to go when you were talking about modularity in the boiler room and that. But
we've done that, and one of the hardest parts sometimes it's getting the contractor, because they're great pipe fitters, but not everybody's a smooth eye. I mentioned that earlier. So if you can drop a piece of equipment that's ready to go, with as many connections as you can make, where it's supervised with people that have done this before, and get them to a job site where, then it just connections to the system. It makes sense. I've done that before. I've done it with Mura boiler a couple times, very successfully. I've done it with other brands as well, but it's definitely can be cost savings, right? And plus, it's not just, it's a confusion on the job site. I remember Kevin coming to your place. I mean, everything's happening all at once. It was a fun project. There was, I'd rather be there this time of year rather than when I was there, I think in December.
November, December. Yeah, right.
Yeah, it was cold, very cold in that. But Jamie, you had mentioned earlier you were going down a path relative to like labor, energy, and efficiency overall with things. There is a process. It's part of lean manufacturing where you do what's called value stream mapping. And basically, what you're looking at first, I'll just give a very rough overview here, not going too deep, but just for our listeners. In value stream mapping, you basically take a look at defining your borders. When do you start the process? Where within your process do you start, and where do you stop? And there's a sequence of events that occur between starting and stopping, and each of those events consume resources. Those resources can be human labor. They can include utilities like electric, water, natural gas, and CO2, for instance, or nitrogen in some cases. And then and then of course you've got your ingredients, your various types of ingredients that you use to your hops and things of that nature. And so if you take a look at what goes into each of those different elements of a value stream map, each of the processes themselves, and you take a look at then what goes out of the process. For instance, in an ingredient standpoint, there's a term called mass balance. And we take a look at, for instance, in the brewing industry, we look at extract efficiency, right? That's the mother lode, right? In the brewing industry is how much sugar can I get out of this volume of malt that's coming into the system. And so understanding, what went into the system and what went out of the system is very important. And so, and then at the end of the day, you evaluate what's called your current state, and then your future state. So in a current state, it's where are you at right now, and then you put benchmarks and goals together to achieve a higher level of efficiencies, and whether that's extract efficiencies or human labor or utilities and that sort of thing, and then move forward. That model typically finds larger returns in a larger plant. If you're at 50 barrels and above, say size brew house, you're going to see that effort associated with that. You're going to see a higher return on your investment because your volumes are higher. If you're at a 3, 5, 7.5, maybe even a 10 barrel plant, there's still efficiencies to be gained, but the volume of the efficiency, if it's a couple 3% on a mash, let's say a grist load of, I'm making this number, let's say 1,000, 500 pounds versus 1,000 pounds. Is going to have a bigger impact. So that's something that if our listeners want to take a look at, just Google like lean manufacturing, value stream mapping, and there's tons of information out there on the web that'll help you with that.
Kevan, from your perspective, you're trying to build this kind of efficient production, but you're also trying to produce the highest quality beer that you can, because especially as you're building the brand and the idea for customers of what this beer is, you want them to connect with the quality of it, and they don't care so much from their perspective about how efficient it was for you to produce. They want the best tasting beer and a cool environment to drink it in. So from your perspective, how do you balance from the position of a smaller brewery operator, the kind of process efficiency, the things that you do pay attention to on a very routine and regular basis, versus some of the data that you can collect that may not necessarily at this point help you, achieve the current bottom line that you need to achieve, and then how you then project out, maybe as Vern says, to what you will need to look at in the future as you then tackle another phase of that. For you right now, what are some of those kind of key performance indicators, those data pieces that you connect to at this scale that you find really meaningful?
Oh yeah, that's a lot to try and answer there. I'd say
it wouldn't be the Craft Beer Brewing Podcast if I didn't ask you a very large, voluminous question with so many different perspectives in it.
Yeah, so. I'll try to keep up with that one. If I skip anything, we'll circle back and you just let me know. So I'd say as an owner and brewer, like you guys are all talking about, my headspace is less involved in thermodynamics and not necessarily how the boiler is functioning, but paying attention to the overall grist load, what my grain bed depth is in the lauter-tun, because like Vern's talking about, if you're too thin or too thick, you can get increased beta-glucans, you can get too much tannin extraction, you can end up too thin, you might get more haze-forming particles. So from a brewer process standpoint, to pay attention to, more like isn't mashing correctly, but the enzymes convert. Am I hitting my step mash temperatures? And then that goes through the system. When I'm boiling, what's my boil off rate? Am I boiling it too aggressively? Am I getting the hop rate that I want? So it's kind of more chemical and timing. Step. I'm holding the correct step temperatures for the correct periods of time. That way, down the road, the beer ends up with the right body. It's not too thin. It's not too thick. It's not too hazy. And so all of those things kind of come into play as far as how my day is built. Again, going back to the efficiency of being the brewer and the owner. On this system, the way that it's set up, where most batches I can brew in about 6 hours. I can be hit strike water and then be knocked out in about 6 hours, be cleaning up by myself, or sometimes my other brewer, Ryan, is here to assist. And we work together, or we work independently by ourselves. And regardless of, well, not regardless, I guess it depends on what little foibles pop up during the course of the day, but generally 6 to 7 hours per day. From my concerns regarding the customer experience, we have a whole team of wonderful people that can handle the front of the house, the kitchen, that put out a consistent product on that end. So as an owner, I have to be mindful of, what does the environment look like? Is it clean? Is service quick? Is the food coming out correctly? And fast and hot and all those things. So there's a lot of gears that are constantly spinning in my head. But as it relates to beer, we just I do a lot of analysis here in the lab. I have a microscope, so we do yeast cell counting and staining for viability and vitality. Obviously, we do the normal things like checking specific gravity and pH, ensuring that we have consistency and quality in that. We do a lot of taste tests. I fortunately have an anti-par C box. We measure the consistency and quality of the beer in the tank and the cellar after fermentation. So we can measure the volumes of CO2, dissolved oxygen at parts per billion. So those are all things that we evaluate along the way. If a beer is not good, then we don't serve it. But thankfully, that has not been the case so far. So fortunate from that standpoint. So there are a lot of metrics where we measure and evaluate the chemical, physical properties, and also in sensory, to make sure that the beer that we're putting out is of highest possible quality. And being 2 years in, we're still definitely learning. There's definitely a learning curve the first 6 months learning the big boy system. But I think we still put out some pretty good product. But every batch is an opportunity to improve upon what has been. So we keep taking those chances and taking little steps forward. Sometimes we take a step back, but every day is a learning experience, and we hope to be here for the long haul.
For sure. Well, I can't believe we've been talking for over an hour already. Let's kind of sum this up, Vern, from your perspective. What are some of the key takeaways for craft brewers listening out there that you would encourage them to think about as they are optimizing their processes here, hot side processes?
I think there's really a couple of key takeaways. One is understanding the relationship between a process variable input change and an output that you're studying. So that output could be your sugar level and or a color or whatever the factor is that you're looking at. And being able to understand what that relationship looks like. Is it a simple bang kind of a relationship, or is it a more complicated P&ID, or is it a multivariate predictive model control type of a whole series of input variables to affect a certain output variable? And being able to clearly understand what those relationships are, so that you can manipulate those relationships in a way that's productive. The second takeaway, I think, is really understanding from an overall plant efficiency standpoint, is taking a little time to maybe do a value stream map. And all of the breweries that I've gone in and talked with the brewmasters, they do this. They just sometimes don't know it's a fancy term called value stream mapping, but they know this stuff, and they're very conscious about waste in their plant and reducing waste in their plant. But for those who want a little more information, like I said, Google value stream mapping and lean manufacturing on the overall efficiency side of things. And then as far as understanding cause and effect analysis, do a little bit of research on the DMAIC Six Sigma model. Or give me a call. I love this stuff, and I'd be more than happy to share my experiences and thoughts with our listeners.
Sure. And then Matt, from your perspective, some key takeaways, for folks that are thinking about, how they design their hot side process here.
Well, whether it's you're designing it or have something existing, remember steam production is costing you anywhere from $10 to $15 per 1,000 pounds of production. Recovering your condensate as much as possible, maintaining your system. I think the quickest payback in any system are steam traps. The right trap, right application, making sure they function right, making sure you have them placed where they're supposed to be. Pipe insulation will jump up to number 2, and then boiler efficiency. I mean, there's a lot of things you can do. Controlling conductivity in your boiler is important. Adding economizers to the boiler system. NOx emissions, it depends on what you're looking for, but there's a lot of efficiencies in the steam system that if you're doing it right, good for you guys. But if you're struggling, same kind of the concept, step back, take a hard look at it, see what you can do to, fix those efficiencies, because, Kevin, you're probably spending $25 an hour to operate your boiler, so, and it sounds like basically set you up right the first time and you're managing it right. These things don't run without maintenance. Stay on top of it. Stay on top of your chemicals. Stay on top of your water treatment. It doesn't matter the brand. That's probably one of the most important things I can even suggest on any boiler system. Chemicals and pre-water treatment for any boiler system is really key.
Awesome. That is a great place to bring this to a close. Thanks again for joining us for this special hot side process focused episode of the podcast, brought to you interruption free by Mura. Visit muraboiler.com, MIURA boiler.com for more information on their lineup of steam boilers, boiler water treatment systems, monitoring and control systems, and more. We will be back Friday with another brewer conversation. But Kevin, Matt, Vern, thanks for sharing your insights into hot side process optimization. Cheers.
Cheers. Thank you very much.
Thanks for having us.
This podcast has been brought to you by Craft Beer and Brewing Magazine, for those who love to make and drink great beer. To learn more or to subscribe, visit beerandbrewing.com or find us on social media at Craft Beer Brew.